For this question, we are given a volume of a gas, the temperature, pressure of 105, and we're asked to calculate the mass of a gas. So in this case, we have pressure, temperature, volume, and number of moles, okay, which we can find from mass or vice versa. So all four variables are fluctuating. In this case, we're dealing with the ideal gas law. So anytime you see a question that has any mention of mass or moles of a gas, we know we're using the ideal gas law. Okay, the PV equals nRT. It asks me to calculate mass, so the units for mass are grams, and I know that moles and grams can easily be converted. These are just two separate units that deal with amounts. So I can convert one to the other, no problem. So in this case, if I'm looking for grams, I don't have mass as part of my ideal formula, but I do have moles. So if I solve for that, I can just do a unit conversion into grams. So if I'm trying to isolate N, we have to get rid of the R and the T. Again, when you're rearranging equations to isolate variables, you always do the opposite operation. So right now I'm multiplying N by R and by T. So the opposite is to divide by R to cancel and to divide by T to cancel. I need to do the same thing over on this side. So I get N is equal to PV over RT. R is our ideal gas law constant, which is always equal to 8.314 kilopascals liters over mole Kelvin. Okay, we've got these kind of big ugly units here. Easy way to remember is kpals over molks. So I want to sub in everything. We need to have these four units for our temperatures, pressures, amounts, and volumes. Pressure is 105 kilopascals. Volume is 0.785 liters. Initial temperature is 198 Kelvin. And my ideal gas law is 8.314 kilopascals liters per mole Kelvin. Check your units. Kilopascals over kilopascals will cancel. Liters over liters will cancel. Here I have Kelvin times something that's over Kelvin, so those will also cancel. We end up with our units in moles. So when we multiply this all out, again, when you're subbing that in, make sure that these two terms are in brackets in your calculator. I end up with an answer of 0.05007 moles. The answer asks for the mass, which is in grams. So I have to do a unit conversion. To convert these, I need a ratio that relates grams to moles. That ratio is the molar mass. The gas is xenon. Molar mass of xenon is 131.29 grams per mole. I just get that off the periodic table. So that's my ratio of grams to moles, which is basically the equivalent of saying 131.29 grams is equal to 1 mole of xenon. So I'm going to take my previous answer and convert this to grams. So 0.05007 moles. I want to end up with an answer in grams, so I need to multiply by my ratio. We'll put this over 1 to make it a fraction, and then we'll write our ratio of grams to moles also as a fraction. So if I'm trying to end up with my answer in grams, I need moles to be in the denominator so that moles will cancel, and grams in the numerator. So it's 131.29 grams for every 1 mole of xenon. If I multiply that out, so my number of moles times 131.29, and we get 6.5737 grams. Sig digs, go back to the original question, and we want to have our answer with 3. So I'd round this to 6.57 grams. Since this is a numeric response, I would record that as 6.57. Your decimal has to go in one of the two middle spaces, and you would fill in the bubbles 6.57.